Have you ever been puzzled by a programming error that just doesn't make sense? If you're scratching your head over variable scope in C, you're in the right place. Today, we're diving into a common question. Why can I jump into the scope of an allocad variable, but not a variable length array? I totally get it. It can be incredibly frustrating when your code compiles fine one way, but throws errors when you try something different. You're not alone in this confusion. Many developers have faced similar issues. Let's take a closer look at the specific question at hand. One user shared a test program that fails to compile with the error message. Jump into scope of identifier with variably modified type. They were curious why this happens with variable length arrays, but not with allocad variables. Sound familiar? Let's explore this together. So, what's going on here? The C standard has specific rules about variable scope and lifetime. Variable length arrays, or VLAs, have a different lifetime compared to memory allocated with Alloca. Understanding these differences is key to resolving the issue. And stick around. By the end of this video, you'll not only understand the difference, but also how to effectively use both Alloca and variable length arrays in your code. To understand why the user can jump into the scope of an object created with Alloca, but not a variable length array, we need to look at how these two types of memory allocation work. First, let's discuss variable length arrays. When the user declares a variable length array, its size is determined at runtime, and it has a specific scope. This means that if the user tries to jump into the scope of this array using a goto statement, the compiler raises an error. On the other hand, Alloca allocates memory dynamically on the stack, but it does not create a variable length array. Instead, it allows the user to allocate memory that is valid until the function returns, regardless of scope. This difference in memory management is why the C standard permits jumping into the scope of an allocad variable. The memory is still valid, and the compiler does not enforce the same scope rules as it does for variable length arrays. Fun fact, did you know that the goto statement has been a topic of debate among programmers for decades? Some love it for its simplicity, while others warn against its potential to create spaghetti code. What do you think? Now, let's look at the answers provided by other users. This user explains that the reason you can't jump into the scope of a variable length array, or VLA, is that the compiler needs to initialize it at runtime. If you use a goto statement to jump over the initialization code, it can lead to a segmentation fault because the VLA hasn't been set up yet. In contrast, when using Alloca, the compiler can't detect a seg fault during static analysis. So, while the logic is similar, the behavior differs. The C standard explicitly prohibits jumping into the scope of a VLA to prevent these issues. That's it for that answer. Let's take a look at another one. This user explains that jumping into the scope of a variable length array, or VLA, poses issues with deallocation and the use of sizeof. If you try to use sizeof on a VLA, its size is unknown at compile time, which leads to problems. In contrast, when using Alloca, sizeof can be computed because it behaves like a pointer, making it a valid operation. Here's a pro tip. When working with variable length arrays, consider using functions to encapsulate your logic. This way you can avoid scope issues and keep your code clean and maintainable. And there you have it. Now you understand why jumping into the scope of an allocad variable works, while variable length arrays do not. Keep experimenting with your code, and don't forget to subscribe for more programming tips and tricks.